This short information video is on the topic of Embodied Conversational Agents, or ECAs, in virtual reality. In this video, we will first explain what an ECA is by examining the terms embodiment, conversational, and agent in turn. Following this, we will examine each of these in more detail to understand how and why these agents are created. So let's first try to understand what an ECA is by examining the name itself. First of all, an embodied conversational agent is represented by a virtual body. That is to say, it is embodied. This physical or digital representation of an ECA is often used to communicate non-verbally, with gestures and movement. Secondly, the ECA is conversational. It interacts with users through dialogue, understanding their speech and responding appropriately. Finally, the actions of an ECA are controlled by a computer that tries to mimic human behavior, as opposed to an avatar whose actions are controlled by another human. Now let's examine these components more carefully. First of all, let's look at how ECAs are embodied. We'll be looking at an overview of the technical process of ECA creation in VR. Let's bear in mind that ECAs can take many forms, but as we are looking at a virtual reality implementation, let's stick to 3D avatar models. These models are digital representations of ECAs in the virtual world, designed to make interactions feel natural and engaging. Modeling allows avatars to mimic human appearance, and animation systems allow avatars to mimic human movement. Models of avatars can be created using software such as Blender or Autodesk Maya, which enable designers to craft figures with realistic textures and animations. Most facial animation is created from the use of blend shapes, which work by interpolating between different facial expressions. For the body, the model also comprises a virtual skeleton, which is composed of bones and joints. A popular technique used to animate the skeleton is inverse kinematics, or IK. IK allows the end effectors, so hands or feet, to be positioned accurately in 3D space, with the rest of the limb adjusting naturally. On the software side, platforms like Unity and Unreal Engine are commonly used to build VR environments and animate ECAs. These engines provide the tools necessary to integrate complex behaviors and interactions into the VR space. Devices like the Oculus Quest and HTC Vive offer high-resolution displays and motion tracking, which can be used to create an immersive virtual reality experience for the user. Sometimes the interactions components of the ECA are coded and implemented in the VR software itself, but many SDKs or software development kits exist that provide pre-built modules and APIs to help developers create ECAs. We've briefly discussed how virtual bodies are typically created and animated through both facial and body movements. This animation can be used for the ECA's non-verbal communication, which includes eye gaze, facial expressions, and gestures. Such communication is often driven by algorithms that interpret the conversation context and generate appropriate body movements. Eye gaze can be used to indicate the agent's focus, while expressions and gestures can convey meaning and emotion more powerfully than words alone. As a result, most research in non-verbal communication examines the effects of eye gaze, body orientation, and other factors on elements such as the user's trust and the sense of co-presence between the user and the agent. Now let's examine the conversational aspects of ECAs. We'll be looking at both speech recognition and speech synthesis. Speech recognition is an interdisciplinary subfield of computer science and computational linguistics, focused on developing technologies that enable computers to recognize and translate spoken language into text. Advanced speech recognition models leverage cutting-edge techniques in machine learning and deep learning to achieve high accuracy and efficiency. These models also recognize speech in real time, ensuring a user-friendly and smooth experience with word error rates as low as 5%. Currently, a variety of speech recognition models are available from both major industry players or free open source options. As spoken responses are required for ECAs, text is converted from text to speech using advanced speech synthesis techniques. Modern systems use neural networks, such as WaveNet or Tachotron, for natural-sounding speech generation, which is then played back to the user through speakers or headphones. Modern extended reality devices are typically equipped with microphones and speaker or headphone outputs. Thus, by using speech recognition and synthesis, modern conversational agents can engage in elaborate real-time conversation with humans. We discussed how the ECA uses speech recognition to convert the user's speech into text. Then we saw how it uses speech synthesis to convert its own text into speech. But what does this text contain, and how does it decide what to say in response to the user? So while we discussed dialogue in relation to the conversational aspects of the ECA, it's also heavily related to the agent properties of the ECA. So let's discuss the agent aspect of ECAs in more detail, building on our existing understanding. The agent aspect of an ECA refers to its role as an autonomous entity capable of performing tasks, making decisions and interacting with users. These tasks can range from generic tasks, such as engaging in casual conversation, to more specific tasks, such as booking a restaurant. From the agent perspective, dialogue management is the basis of the ECA's broader decision-making and task execution capabilities. At the heart of any dialogue system are key components that include natural language understanding, dialogue management, and natural language generation. Natural language understanding is responsible for interpreting user input. It involves tasks like intent recognition, so identifying the user's goal, and entity recognition, which picks out the relevant input information. Dialogue management acts as a system's brain, determining the appropriate responses based on context and the user's intent. It keeps track of the conversation state, managing the flow, and deciding the next actions. Natural language generation converts the system's responses into natural language that the user can easily understand. It's the process of crafting the natural language text with appropriate slang and colloquial expressions. So the ECA's dialogue system is crucial for the ECA's task and decision-making processes. As we said before, ECA uses speech recognition to convert the user's speech into text. It uses speech synthesis to convert its own text back into speech. But this alone is not enough. As an agent, the dialogue system decides what to say and how to say it. It helps the agent understand the context of the conversation and user intent. Another aspect of agents is personalization, so adapting the conversation based on user preferences, past interactions, and specific needs of the user. So while a chatbot, for example, can only respond, ECAs can understand, learn, and do. In summary, the agent aspect of the ECA encompasses its autonomy, its ability to act independently, and carry out tasks itself. So now we can understand how embodiment, conversation, and agent all relate to each other. So the agent has a conversation with the user, converting text to speech and vice versa, but it needs to generate all these responses in real time, understanding the user and making its own decisions about how to verbally respond. It also decides what non-verbal communication it should be displaying, relating back to embodiment. Together, these elements make ECAs function as intelligent, autonomous entities capable of providing meaningful and effective interactions with users, understanding its environment and you, the user. This video gives an overview of what an ECA is, in the context of human embodied ECAs in virtual reality environments. We hope to have helped you understand the different components that give ECAs their name. Embodied Conversational Agent.